so number 19 is asking us to find the magnitude of a horizontal component of this given information. So the first thing, before we do anything else, I think we should talk about how many degrees are between each hour hand. So like, you know, there's 12 sections here, you know, there's, well, or even, maybe even just think about it like this. Let's think about it like that and like this, and then recognize that this is going to be 90 degrees, you know, from here to here, 90 degrees here, you know, all the way around. So that means each of these sections would be 30 degrees. So we have 30, 30, 30, right? Make sense? Okay, so now let's draw 7 o'clock. The hour hand on a clock points to 7. So that's going to be right here. Okay, so we'll just draw that. Okay, so there's our vector. If the vector represented by the hour hand, okay, has a magnitude of 5 inches, so that means our magnitude is 5. That's like our hypotenuse, right? Okay, so here's what I'm going to do, class, and this is what you normally will do. I'm going to build this. I'm going to treat these green lines as if they are an x and y axis, okay? And so I'm building this little right triangle right off the x-axis there, and that is where you will normally build it in the future. In Algebra 2, there'll be all kinds of opportunities for you to draw these kinds of right triangles. So the question is, what is this degree measure right here, from here to here? Well, how many degrees is it from here to here? Well, 60 degrees. I hope you can see that. So this is a 60-degree angle. And so what it's asking for is the magnitude of the horizontal component. In other words, what it is asking for is how big is this leg of the right triangle? Once you break it down like that, it becomes actually very easy to solve if you understand trig functions. You could also use your 30, 60, 90 triangle, but I'm going to use trig functions because I love trig. So I'm going to say that I'm going to use, because this is from this 60-degree angle, I want the adjacent over the hypotenuse. So I've got the cosine of 60 degrees equals this unknown x over 5. And then you can cross multiply, solve for x, and there you've got your horizontal component. Kind of cool, isn't it?